Mathline has really opened my eyes to active learning.
I like that professional stimulation that it gives me.
I've been teaching for 20 years now, and Mathline is the best professional development program that I've ever been involved with.
Education reform. Across the country, in big schools and small, teachers are on the front lines of the movement to improve education. New standards, benchmarks, and assessments are calling on teachers to change not only what they teach, but how they teach. Where are teachers going to get the continuing support, knowledge, and skills to respond to these changes? Through professional development. But how can they fit it into their demanding time schedules? PBS Mathline. This year-long technology-based professional development project offers far more than traditional short-term workshops.
With a weekend or a one-time workshop or seminar, I think you get kind of jazzed for the temporary moment. With Mathline, it kind of gives you that hype all the time.
Mathline gives teachers the professional development needed to improve mathematics education and help all students succeed. Gone are the days of isolation. Through a combination of video and online technology, teachers can communicate with peers anytime, anywhere.
The fact that teachers can get online 24 hours a day and have that opportunity to get information, to access information, to share information, and get questions answered is one of the most exciting aspects about it.
Mathline is a flexible and cost-effective program created with the advice of the National Council of Teachers of Mathematics and teachers themselves. With thousands of teachers participating, Mathline is one of the nation's largest year-long professional development projects utilizing technology. Mathline is made up of 3 distinct programs: ESMP, the Elementary School Mathematics Project, MSMP, the Middle School Math Project, and HSMP, the High School Math Project, with a focus on algebra. Reflecting the vision of the NCTM standards, the projects are designed to support state and local frameworks, standards, and initiatives.
I don't think I could go back and teach traditional lecture methods. I don't think I could even, in good conscience, sleep at night teaching a traditional class, because I would think I would be shortchanging those kids.
Mathline provides a rewarding opportunity for teachers to learn strategies and content and use technology. Teachers form an online community led by a facilitator who is also an experienced classroom teacher. Each Mathline project also offers a series of video lessons. The lessons were taped in classrooms all across the country. They provide a context and structure for the online discussions. Round the clock, teachers can post questions, exchange ideas, and share strategies. Mathline projects demonstrate exciting ways to incorporate new teaching and assessment strategies and content standards into day-to-day instruction. PBS Mathline's ESMP, MSMP, and HSMP are services of local public television stations that provide ongoing support to participants throughout the year. There are teachers all across the country currently participating in Mathline. Here's one from Florida.
When I moved into the classroom to be a math teacher, I was scared to death. I needed a lot more than just knowing my basic skills. And that's why what I'm doing now with the Mathline is so great. All right, what is our 5th planet? I want my students to expand their reasoning skills, their critical thinking skills, their ability to look at a problem, figure out how to solve the problem.
Oh, crap. That's a mistake.
The video shows you what's going to happen. I might do a lesson very similar to the way that they have presented it on one of the videos, or I may change it. The online computer service is very helpful. It gives teachers a chance to have a discourse. That's very important to me, knowing that there's other people out there going through the same things I'm going through. I can go on the Mathline at any time I want to. I don't have to go on it Monday through Friday. I've used it on the weekends a lot. It enables me to do what I need to do when I want to do it. I use Mathline because it is there to give me professional ways of doing things. I want my students, when they leave my room, to say, that was a pretty good math class. Mathline has a lot to do with why I'm becoming a better teacher.
The Elementary School Math Project for teachers of grades K through 5 focuses on the unique needs of elementary school teachers. ESMP keys in on how mathematical topics expand as children develop more sophisticated approaches to problem solving. It concentrates on the many decisions teachers make over the course of a lesson to ensure that all students learn. And the Elementary School Math Project demonstrates how a teacher refines the teaching of concepts over several days.
Who can tell me one thing that you know about tessellations? Katie.
Circles and ovals don't tessellate.
Alex, why?
Because they're round and they don't have angles, so they won't tessellate.
Today, everyone was at a center, and it will go on for 6 days. It's important that they use a variety of manipulatives within the area of tessellation. But I think based on comments that they've made, based on group discussions, that they really have the basic understanding that a tessellation has no gaps, has no spaces, and that it goes on forever.
Set, go.
MSMP for teachers of grades 5 through 8 focuses on these crucial years when students must master ever more demanding and comprehensive mathematics. The basic goal of MSMP is to support teachers in ways that will result in stronger performance for all students. This project puts the NCTM standards into action.
Okay, we got the data entered in the computer. Let's go back to class and take a look at it.
We're delighted that there are projects such as Middle School Math Project run by PBS that is trying to reach out and help middle school math teachers become the very best that they can be.
The equation, we now know what the stretch factor is.
HSMP, Focus on Algebra, concentrates on the teaching and learning of algebra from a functions approach. The program demonstrates instructional strategies, models creative applications,
First, we need to measure the empty graduated cylinder.
and addresses issues such as active learning, assessment, and inclusion.
I want them to understand where mathematics fits in their lives. I want them to understand how technology, in addition to mathematics, goes hand in hand, how those two are tied together.
Look how close I am. I'm like one little point off.
There are a variety of support avenues that teachers can look to as they're trying to make changes. Programs like PBS Mathline that allow teachers to carry on a conversation about the kinds of reform ideas that they're trying to put in place.
Mathline is receiving wide recognition. Some nationally elected officials even went online to try it out. Administrators see it as a valuable and cost-effective approach for teacher professional development.
I think the Mathline project has some real neat possibilities. The videotapes contain real teachers teaching real lessons in real contexts, and I think that's critical. But the other piece I think that's going to really make it unique and work is the online networking that teachers can do with other teachers.
In fact, some teachers have called PBS Mathline one of the best development programs they have ever taken.
My hope for this project is that we look at each other as professional friends and that we can take the best of what other people are willing to share with us.
Mathline, online and on demand, keeps teachers up to date on the latest in math content, strategies, and assessment. Mathline, giving teachers a way to improve student learning now.
Funding for PBS Mathline was provided by the U.S. Department of Education, the AT&T Foundation, the Carnegie Corporation of New York, and the Corporation for Public Broadcasting. To learn more about Mathline's video and online resources or other educational programs, visit PBS Online at www.pbs.org. You may purchase videos or program materials online or by calling 1-800-645-7354.
I've been teaching for about 9 years now, and this is my first year working at the Children's Workshop School, and I'm teaching a first, second grade class. At the Children's Workshop School, all of our classes are multi-age group, and the children move through the grades together, which is also unique because they really know each other. And the reason that we use a split is that children develop at different rates, so they work together, and it's just a nice mix to have older and younger kids together. The educational goal of this lesson is to have the children work with money to better understand number sense. Nadia, can you read this for us?
Good morning. Today is Tuesday, June 11th.
Great. I was wondering, I have here our bank full of money. Who could come up and show us how they can turn the date into money? Who can show us one way to make 11 cents? Callie, could you come up and do that? And as she does it on the carpet, I'm going to write it up here. You need to sit back so she can do it.
1 dime and 1 penny.
Great. And can you just leave it right there? And right below it, can Henry come up and show us another way to make 11 cents? I tried to make math lessons that somehow can apply to a child's real life. So in terms of having the children work with money, I have them use real money because when they leave this building, their parents use real money, they get real money as allowance, they don't get plastic money, and they also understand the value much more when it's something real and tangible. 11. So 11 pennies. At one point, we had exhausted all the different ways you can make 11, but this one boy was determined he can make it another way. Marshall? Okay, show us how you made 11 cents.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It looks different, but it's not. It's the same as this one.
How is it the same?
Because he put it a different way, but it's still the same.
So even though he used the same coins, right? 1, 2, 3, 4, 5, 6 plus 5 is 11. He changed the order, but it's still worth the same amount of money. When I see things like that, it is okay. If he can show it a different way and get other people to understand it, that's great. He's able to challenge himself and challenge the other children to think the way he's thinking. Is that different?
No. I saw the...
It's still worth how much?
11 cents.
Right. So we can use the same coins and change the order, but it will still be worth the same amount of money. Okay. You all did a great job making 11 cents. What I want you to do now is I have 15 cents in my pocket, and I want you in groups to figure out how many different ways I can have that 15 cents. You're going to work together in groups of 4. You're going to take this money card and you're going to put the penny card, the nickel card, the dime card, and the quarter card on it. And going across, you're going to come up with as many combinations. So if you did it one time, you might use, put a dime and a nickel in its spot. And you're going to come up with as many combinations as you can. Ariel, what was the second way your group made 15 cents?
15.
You want to just check that for us? Make sure there's 15 there?
There's no quarters. What did you say? Quarters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
Excellent. Number sense is understanding the different ways that a number can be made. For example, the numeral 10, all the combinations to add up to 10, 1 plus 9, 2 plus 8. So that's really number sense. And in terms of coins, it's the same thing. How many pennies do you need to make $1 or to make a dime? Wow, you did such a great job. There's one more column, row. Think there's another way?
No.
Are you sure?
No. I don't think this is my combination.
You don't think there is? Did you try anything else?
15 pennies.
There's 15 pennies.
2 nickels. 10.
You think you got them all?
I don't know.
Ashley, you think you have every combination possible for 15 cents?
I can't think of another way though.
Ashley, I can't think of another way either. You all did such a great job, and I loved how you were working together. Okay, so Nadia, you're going to write that down. You used 1 nickel and how many pennies? And you want to do it in the next empty column. Count them so you know how many. Okay, 1, and what word's that? Penny. So you need to write that right there. Great. Can you think of any other ways that you could make 15? So we're going to take these off. Okay, and I see you already wrote 3 nickels.
You read that, Ryan? I mean this.
Oh, wait, he has another one. How did you do it that time? And you want to go to the next available space. That's why you have to keep going down. Okay, I'm going to say, when you write that here, when you write 15 here, what word does that say?
Dimes.
Dimes, and it's, what did you write here?
15.
So you mean 15 pennies, or do you mean 15 dimes?
15 pennies.
Okay, can you just put an X in that so we don't get confused? Okay, now, come all the way down here. You used how many dimes?
1.
Great, and you used how many nickels? 1. Terrific. Okay, I need everybody sitting down now. And then we came back to the group, and when we made the recording, what was interesting is they had to be able to take the 2 dimes, well, in this case it would be 2 nickels, and let's say 5 pennies. They had to be able to say, under the nickel column, write the number 2, as opposed to writing 10 cents. I have 15 cents in my pocket, and I need you to help me figure out all the possible combinations it can be. And then I'm going to show you how I made my 15 cents. So we're going to start, and Yuga's group, can you open up your recording sheet and give us one of the ways that you made 15 cents?
1 dime and 1 nickel.
1 dime and 1 nickel. It's one way to make 15 cents. 10 cents plus 5 cents equals 15 cents. Ariel, can you open up your recording sheet and give us one way your group made 15 cents?
15 pennies.
15 pennies equals 15 cents. Brian, can you look at your sheet and tell us one way your group came up with 15 cents that's different than the combinations we already have?
3 nickels.
5 plus 5 plus 5 equals 15 cents. Great. Giselle, does your group have another way?
5 pennies and 10 cents.
5 pennies and 1 dime? 10 cents plus 5 cents equals 15 cents. And then in the end, I asked one girl to just guess which combination I had. And then I showed her the one I did. Come and look. You ready? I'm going to take it out of my pocket. Tell me if what you guessed is right.
Oh, no.
How did I make it?
A dime and... That was my deal.
And I chose a dime and a nickel because I wanted them to realize that to carry a dime and a nickel is a lot easier than carrying 15 pennies or 2 nickels and 5 pennies. When we finished coins in my pocket, I wanted the children to start thinking about greater than, less than, and equal to. So I made 2 groups, a group A and a group B, and I put up different coin values. And I was asking the children to really think about the value of coins and how to add them. I put up 2 groups of coins, group A and group B. By raising your hand, who can tell me the value of this group? Okay, Marshall?
Quarter.
Mm-hmm.
Nickel. Penny.
What does that add up to, a quarter, a nickel, and a penny?
$31.
Great, that's 31 cents. Can you tell me the value of group B, Marshall?
$0.33.
33 cents. For some children it's difficult because a quarter and a nickel is both silver, and they're not really familiar with what it looks like, so they need some guidance with that. Okay, now here's the challenge. Who thinks they could make group A and group B by moving the coins so that both sides are equal in value? Jillian, could you come up here and do that for us?
Take 2 pennies out. This one. You win.
Okay, where are you going to put this one? Oh, I see what you're doing. You took 2 pennies off, and now they're the same. And Jillian, how much is this side worth?
30.
And how much is this side worth? Okay, now you have 2 pennies in your hand. Do you think you could use those 2 pennies and put them on the board and make them even?
Yes. Yeah, that's what I was going to tell you. That's what I was going to say.
And now what do both sides equal?
32.
Excellent job. I'm going to change this one more time, and this is a really, really hard one. This is a big, big challenge. So watch what I'm doing. Examples got harder as we went along. And the last example had a quarter and 4 pennies on one side, and a quarter and a dime on the other. What do we have to do to make group A and group B be equal? What do you think, Mary?
Take off the pennies and put a dime.
Okay, but we have to use the value that's up there. What can we do to this dime? Because we can change, it still has to be 10 cents, but we can change it.
10 pennies.
Could use 10 pennies. What's another way we can do it?
2 nickels.
Mary, could you come up here? Would you change this dime to 2 nickels? Take down the dime. Okay, Mary, your idea of 10 pennies would also work, but I don't have enough cutouts of pennies, so we're going to go with the 2 nickels. Okay. So now 29 cents and 35 cents. How can you make them equal value? What are you going to move around here?
29 and 35.
How can you make them look exactly the same? Okay, go ahead and do it. So now they have to really think about the value of money because 4 looks like more than 2. Then from that we played the money exchange game. The children have a lot of experience playing this game, and when I first start the game, they only use penny and dimes. because that's a much easier exchange when they understand that 10 pennies equal a dime. And this time I'm going to give you a dollar amount that you need to play up to. So you're going to play in groups of 4, and you're going to take out your card, and you're going to put out all the cards, the penny, the nickel, the dime, and the quarter card. Each group is going to get their die with the money value on it, 10 cents, 1 cent, 5 cent, 4 cent, 3 cent, and 2 cents. Every group gets a container of pennies, of nickels, of dimes, and of quarters. And this time you're going to play to the first person reaches $1. So you're going to have to keep counting as you're playing the game. Mary, what would equal $1?
4 quarters.
Would equal $1. Terrific. Who can think of another way? Eric?
10 dimes.
10 dimes would equal $1. What's another way that you can make $1? Yuga?
100 pennies.
Certainly 100 pennies. Do you think we have 100 pennies?
No.
So you're going to have to make sure you exchange so you come up with $1 another way. Any other ideas how you can make $1? The reason I chose $1 was I knew later on in the day I was going to have them go shopping using $1 amount. So I wanted them to start thinking about coins in terms of equaling $1. For me, it's great to walk around and see how the children are making the exchanges. What do they do when the pennies run out? Or do they just automatically say, oh, 5 pennies and a nickel, I could trade that in for a dime? And I get to see what children really understand the value of money and what children I need to spend more time with. Let's see how much money we have, if anyone has $1 yet. So Marshall, you want to start? The challenge is to have them add up their money. Because again, they have to recognize what the value of a coin is and not just count the numbers. 63 cents. 7 coins isn't necessarily 7 cents or 70 cents, depending on how they're counting. So they really have to work by counting by 1s, by 5s, by 10s, and in some cases by 25s. Giselle, you ready to count yours?
I know.
How much?
64.
Can you show me using the money?
10, 20. What's this?
30.
You cannot keep it.
You have to count by 5s. 35.
35, 40, 45, 50. My turn. 67.
You have 67 cents. So does anyone have $1 yet? Nope, you got to keep playing. When we're playing a game, I often change how you win. Sometimes when we play the money exchange game, we just play for 10 minutes, and at the end of 10 minutes, just count up your money. And there is no winning. Sometimes we play the last person to reach the dollar amount would be the winner. In this case, it was the first person.
I got $1, I won.
And one of the children was very upset because the boy before him rolled and made $1. And he didn't think it was fair because he wanted to win. And that's when you have to keep in mind that these are 6- and 7-year-olds. And winning is very, very important to children. And so I took him aside and I spoke to him. It's just by luck what the die rolls. And it landed on Marshall and he made $1. So you need to really go back there and congratulate him, and the next time you might be the winner. Do you understand that? Because you can't always be the one who wins. That's how the game works. And he went back and he was okay with it, but for a minute there he was really upset. One thing that children love to do is art projects. So I thought if I set up a little store in which they could go shopping to buy supplies to make their puppet, they'd be really interested. Welcome to our puppet supplies store. Today, each one of you is going to get $1 to go shopping at the store. I'm going to give each one of you your own $1, but there are certain rules to the way that you have to shop. Each person's going to get a planning sheet. Every item in the planning sheet is in our store. So the feathers cost, how much do the feathers cost?
26 cents.
Right. And each piece of yarn, Jeremy, cost?
8 cents.
What about the fabric scraps? Yuga?
18.
So what's going to happen is before you can actually go shopping, you have to plan how you're going to spend your money. Down here it says money for supplies, $1. And then there's a box that says leftover money. If you have any leftover money, you write that in here. Now you get certain things free. You get this brown paper bag, which you're going to collect all your supplies in. And then what do you think you're going to do with the bag after?
Make a puppet out of it.
Make a puppet out of it. And you also get crayons, markers, tapes, staplers, all that free of charge. So, Callie, what did you just say to me? And I gave them options of the way that they can do it. They could use money or a calculator. And for some children, using a calculator was a new experience. And that was difficult because they had to understand to hit the plus sign each time. And they had to make sure that they didn't press in an extra number, which is something, you know, we as adults do. We're going to just keep it flat. It's easier, I think. What's the next thing you want to buy?
16.
For how much?
18.
Press plus. Plus 18. Okay, press plus again, and that will tell you how much you spent. My idea behind the puppet supply store is that they go into a store with their parents, and their parents often say to them, you have 25 cents, you can buy something in this store. So they need to figure out what can they buy for 25 cents. And their first impulse is to just pick out anything, and they don't really realize that you can't buy anything. You really have to look at what the price of something is. Tanae, come on up. Let's go shopping. Take a brown bag, your planning sheet, and your money. Tanae, where would you like to start?
Here.
All right, what are you buying? So let's look at your sheet so we can tell. You're buying 2 pieces of yarn?
Yes.
And it's going to cost how much?
6 cents.
16 cents.
6.96.
I'm going to open up your bag. Can you count that as you put it in here?
5, 10, 15, 16.
Okay, what 2 pieces would you like? With the puppets, most children wanted to buy more than what they had, and that's why I purposely made it that they had to figure out exactly what they can buy. Because in reality, you often have to put things back. You can't always get what you want. I want to provide my classroom with a climate in which the children can be risk takers and feel comfortable. There's a real community here in which the children can talk to each other. They talk to each other in a non-threatening way, and the children feel supported and are able to take the necessary risks to become good at math. So I'm setting them up for success. Math is not something they are going to fear. It's something that they embrace, and they're all enthusiastic about it.
Show for you. This is my friend Pinocchio. I'm not Pinocchio. So are you gonna? Inch by inch, row by row, gonna make this garden grow. All you need is a rake and a hoe and a piece of fertile ground.
Funding for PBS Mathline's elementary school math project was provided by the U.S. Department of Education. To learn more about Mathline's video and online resources or other educational programs, visit PBS Online at www.pbs.org. You may purchase videos or program materials online or by calling 1-800-645-7354.
McKinley School is in Santa Barbara, and it sits on a hill sort of overlooking the ocean. It's a neighborhood school. The particular group that I have this year has a pretty wide span of academic background. Some of them show up as having unique challenges, socially and academically. It's self-contained bilingual, which means native English speakers and native Spanish speakers in the same environment.
Adan con Noemi, Juan Luis with Priscilla.
We use language as a tool to learn, and so all students are using and listening to two languages to communicate at different levels of literacy.
Y después vamos a hacer una actividad. So I want to tell you a little bit about what we're going to be doing today, and then give you some time to do it. So I need
There was two areas of mathematics that I was trying to get at, and the one was the number sense, and the second one was the surface area of an irregular shape.
Who watched television last night? Levanta la mano si miraste la televisión anoche. Okay, so raise your hand if you saw television last night and you saw a commercial.
The lesson begins with trying to elicit some discussion from the kids about television and commercials, and basically what's the goal of a commercial, which is to sell an item.
So take a moment and read this with your partner.
Prototipos de las toallas y fijado el precio de cada una.
Priscilla, could you read it in English?
You work for a company that makes paper towels. Your company will like...
What does your company do? ¿Qué hace tu compañía? Chris.
They sell paper towels.
Now it says that your company came up with 3 prototypes. And here they are. Right here. How much does prototype B cost? ¿Cuánto cuesta?
The task of the investigation is they need to pick what they feel is the best paper towel of the 3. And we're choosing to test for 2 variables, price per towel and which is the most absorbent.
$1.12.
Very good. Prototype C. How much is C? Jessica.
$1.52.
And lastly, prototype A. How much? Uriel.
50 cents.
Right. Which is the most expensive prototype? ¿Cuál es la más cara? Adriana?
C.
And the most inexpensive?
50 cents.
And what letter is that?
A.
Very good. At the bottom of your chart, down here, you're given a task. What is your task today?
To find out which item is the best.
Which of the 3 prototypes? Okay, you said that word, best. When you think of paper towel, what does best mean in a paper towel?
The one that's the best valued.
Good. We have, as one thing, money. Which is the best buy for your money? Is there anything else we need to look at? Vamos a ver a otra cosa o nada más dinero? When you guys go to the store with your moms and dads and grandmas and sisters, you just buy the most inexpensive, or do you look for something in particular when you're buying something?
You look for something in particular?
What else might you be looking for in a paper towel?
To clean the messes.
Joseph, you want to add something?
See, I've got the list in front of me and the different prices and how many you get on here. And I think, can I answer this question? Because I think the best towel for your money on this sheet would probably be, can I see the answer?
Well, you can give your guess, sure.
I think the best for your money would be paper towel B.
Mm-hmm. Can you tell me why you're making that guess?
Paper towel C costs $1.52, and there are only 50 sheets per roll. Now and this is only $1.12, and there are 78 sheets per roll. And paper towel A is 50 cents, but there are only 60 towels.
What I hear Joseph doing right now is making some guesses about which paper towel he thinks is the best buy. So we're going to go with that right now.
I think that the number of decisions that we're making maybe is somehow related to how well we're listening to the children. Someone told me once that teachers make more decisions, second only to air traffic controllers. If we're listening to the children and they're saying one thing and our lesson is saying another thing, then we might need to make a decision to go with them.
A is 50 cents for 60 towels, but that it may not be a very good brand because the price is so low and they want people to buy it.
Well, I think B is the best because it costs most money, but my dad has always told me that if it costs a lot of money, it should be good. And there's more paper towels, so it'll last longer than any more of these.
Raise your hand if you have an initial guess as to which paper towel is going to be the most expensive. Levanta la mano si puedes decirme cuál toalla va a ser más cara. Cada hoja va a costar más. Well, let me just call on you. Noemi?
Yo pienso que B es más barata y...
Noemi is saying she thinks C is the most expensive because it has very little sheets of paper and it has an expensive price. Anyone else think that? Okay, ¿y el precio cómo es?
The language question is constantly on my mind. Am I making this clear in the other language? Anything I put out to the children needs to be in both languages. Any note that goes home. So from that point of view, it's more difficult. I think it's a challenge because I'm not separating the students by language groups.
Let's just say you just wanted to buy the cheapest right now. What can we do to find out for sure, which is the cheapest? Take a guess, Diego. How would you find out? Look at your table of information here. How would you find out exactly how much each one cost?
Can Jessica tell too?
Sure, Jessica. How would you find out?
No.
I'm not sure from that point that the students were able to say, oh, we're going to divide the number of paper towels into the price. Partly because the numbers themselves were so difficult. And that's what I speak. And I'm not sure that the students have a really clear sense of exactly how much 112 is in relation to 78. That relationship then between 50 and 60. And so I think they were having a hard time coming up with, well, we need to do this division. So I thought that if I took the numbers to a simpler level, like 2 and 10, or 5 and 10, and 7 and 2 and 14, they would be able to do that type of mathematics right in their head.
So I'm going to give you a little example problem and see if you can follow along with me. Let's say yesterday I went to the store and I bought 2 lollipops. They're really big, beautiful lollipops. And it was $4. How much did each lollipop cost? Raise your hand if you can answer. ¿Cuánto costó cada paleta? Yo compré 2 y yo pagué 4.
$2.
Okay, let me give you another example. You know how I always wear stuff in my hair? I bought a bunch of barrettes. And in this packet of barrettes, there was 5 barrettes. It's 5 of them. And the packet cost $10. My question is, how much did each one of those barrettes cost? Priscilla, what did you do with your calculator?
I put 10 divided by 5 and it said equals 2.
So you think $2? Vete, Renzo. So Priscilla put the $10 in, she divided it by 5, and her answer came out to what?
$2.
Very good. Let's say I went to the store and I bought 2 again. Came in a package of 2. So there's 2 things. And let's say I bought 2 hairbrushes. Brush my hair. I bought 2 of them. And the package cost $14. ¿Cuánto costó cada uno? Nancy.
$7.
$7. Anyone have a different guess? What'd you do, Nancy, to get $7?
I remember that 7 plus 7 is 14.
What did you do, Diego?
14 divided into 2, it came out 7.
So, raise your hand. Would each brush cost $7?
Yes.
Now let's go back to the paper towels. We've been doing these problems. If 2 things cost $4, each thing costs $2. Now let's go here. Let's start with this one. I have 50 sheets. And how much am I paying altogether? Adriana?
$1.52.
$1.52, right. I have 152 pennies. How many groups am I going to put those pennies in?
50.
Why 50?
Because there's 50 sheets.
Very good. What could we do? Priscilla?
Use a calculator.
And if you use the calculator, what would you do, Priscilla?
152 divided by 50.
Why would you put 152 divided by 50?
Because it costs 152 and there's 50 sheets.
Calculators are in the classroom, and the students use them pretty much where needed unless I specify. But this is probably the first time that they've had as messy numbers, both to plug in and to analyze, to make sense of. So I think that was a challenge. And that goes back to the number sense.
Who has something on their calculator? Alma, dime lo que tienes.
304.
Alma has 304.
What I was noticing about when I was going around the room is that some students weren't plugging in the decimal point. So instead of plugging in $1.52, they were plugging in 152, which makes a big difference when you divide it by 50, because you're going to get a decimal answer or you're going to get a whole number. And so the 3 examples we got on the board reflected the students that were plugging in the decimal and then not. So I chose just to have everyone do it plugging in the decimal so we could sort of go on from there and then look about the reasonableness.
Does anyone have something different? ¿Alguien tiene otra respuesta? Donnie, what do you have?
0.0304.
I'm going to give you a couple seconds to think about it. What does this answer mean? You got this answer. What does it mean? It's a big old long decimal answer.
Zero.
I'm going to call an Amber.
The answer is 3 cents.
3 cents for each sheet.
It can't be $3.04.
Why can't it be $3.04 for each sheet of paper towel?
Because that's more money than all of the paper towels put together.
Very good. Amber was looking here. She was looking at these other answers and she was saying, it can't be $304 because the whole thing altogether is only $1.52 for each sheet of paper, and it can't be $3.04 for each one because the whole thing is $1.52. But it could be about 3 cents for each one. Does that make sense? Okay, now that you have your charts laid out, I want you with your partner using your calculator to go ahead and calculate how much each paper towel would cost for both prototype A and prototype B, because we've already done prototype C together, okay?
¿Tú sabes las otras? A ver, ¿me das otra? 1.12 divided by 78. Divided by 78. No more ink.
Okay, good. What's that mean? About how much is each paper towel?
That much?
Okay, look where the decimal point is.
0.0.
1. So if that's
So it's $1.
$1?
1 cent.
Right.
Okay.
I think it's B because it has 78 sheets and it costs $1.12.
I think it could be A because it could be a tell. What did you say?
What? Do you think paper towel C is any good?
Yeah.
For 112, you could get 78 sheets here.
No, but look at what the most is the more better paper towel. You see, so this is more better than B and A. If you buy this, it's gonna get wet, and the paper is gonna be all red. You see?
See, if paper towel C is really good, then you can
If I'm freed up because students are involved and thinking on their own and following their own sort of investigative questions, then that frees me up to go engage with a child who might not be there, but who with some adult sort of gentle guiding and pushing could get there.
Can you see now which one's the cheapest per towel? ¿Pueden ver cuál es la más barata? Very good, Adriana, it's A. But when you go into the supermarket, do you just automatically buy the cheapest or do you look for something else?
You look for the good one.
Okay, good, Diego. What makes a paper towel good?
It lasts more.
Okay.
If it cleans stuff more.
Okay, if it can clean stuff more. And let's say I drop a big old pot of soup. And I go, I dropped soup. And I need to get the paper towels to clean it up. What does the paper towel need to do? ¿Qué tiene que hacer?
It doesn't need to rip.
Good. It needs to be strong. What else? Priscilla?
It needs to be thick so that it can absorb the liquid.
Very good. So let's go with Priscilla's absorbent quality. We're going to see which paper towel is absorbent. Vamos a ver cuál es la mejor para absorber una mancha.
The students are going to have to use irregular surface area to determine which paper towel is most absorbent.
We're going to test the paper towels now for absorbency. And I'm going to show you what you're going to do, and then one table is going to do paper towel A, one table is going to do paper towel B, one table is going to do paper towel C, and we're going to do a comparison. So take up some in here, Amber. Take up some liquid.
How much should it take?
Well, we can talk about how much. Take up as much as you can get right now.
So let's see, take it out.
Okay. Now, put it and drop it in the middle of the paper towel.
It's gonna rip, it's gonna rip.
Well, remember now, we're testing for what, Rafael?
For the paper towel.
The most absorbent. To see which one takes up more water. Why don't we put another drop in? So we'll do 2 drops. See how big a spot that makes.
The hands-on gave them something to do, and they were sort of running the show. I think that the abstractness of the division process and the messy numbers, a lot of them tended to sort of be overwhelmed with that. And this was something that was very concrete.
We have this grid paper, okay? Whoa. And you're going to take this on top, and you're going to just lay it right on top, nice and gentle. And maybe one of your friends could hold it. Can you do that, Diego?
I'll do this.
You guys do this, okay? And then someone's going to very carefully try to trace where the stain goes. And of course, it's not going to be exact, but you're going to try to do the best that you can.
I try to use as many problems as I can that are open-ended, and that students are able to come up with their own way of finding a solution or investigating something, and it's validated.
Now, how could we measure this? What could we do with all these squares inside the stain? Priscilla?
Color them.
Count them. So maybe we'll do this. Let's start with the full boxes. Jerry, can you come and start numbering just the full boxes? 1, 2, 3.
Don't put the numbers.
Yeah, that's good. He's doing great.
4,
7, 8. Do you think you could do this investigation?
Yeah!
When you go to put your stain on, you want about 1/3 of the dropper. Van a usar como un tercio.
Okay, here we go. Is that enough?
Yeah.
Okay, here we go. Okay, you start now. What you get?
When students understand that they are not trying to get one thing that the teacher already knows, but that they're sort of on this journey to try to figure something out, and that they might figure it out completely different from how I might figure it out. I think that gives them a sense of empowerment.
Now I need to count all the squares, all the full squares.
Okay.
1, 2, 3.
Did you mark the whole liquid marker or just the blue mark?
Just the blue mark.
Okay.
Oh my god! This one's holding a lot of it. It's B. It's gotta be B.
We were wrong, it is B. Miss Cravero, it's B, it's not sinking.
I think everything we do in this society pretty much is related to number sense. The goal is that the number sense that's created in the classroom is then used for the children to make decisions in real life.
Okay, listen up. I'm going to ask you now to report your findings up here so we can do some comparing. So I'm going to go to Amber and Chris. How many did you get? How many square centimeters?
57. No, we got more than it. We got 62.
Wendy and Uriel, you had paper towel A?
Yeah.
How many did you have?
124.
Marlene and Joseph?
130.
Jessica and Diego?
We got 113.
Back to Group A, Adriana and Jesus?
134.
Back to Group C, Alma and Alex?
We got 36.
I need another group from Group B. Victor?
127.
Jerry and Adriana, can you give me another one from Group B?
141.
Okay, let's take a look at this chart. What is the first thing we notice about the chart? ¿Qué pueden ver en lo que hay, la información que hay?
When we got the chart up there, I wanted them to be able to see that, which is quite obvious, that the C has a much smaller number than the A and B.
See any patterns going on there? Any differences? Anything that's the same?
The C had less than the other ones.
What about the A and B towels in general? Adriana?
They have higher numbers.
Good. Rather than give a mathematical description of what, and to use it as a comparison tool to make some conclusions about a paper towel.
Okay, why is this one more absorbent to you?
I was thinking the reason there would be a smaller stain on the sea towel because it might be higher quality, and when you drip it on there, on the other ones it would spread more because none of it got absorbed. But if you on the C one, it is absorbed a lot more, so the stain was kind of contained. You know, it didn't get bigger. It didn't spread as much.
So this one probably is what? More absorbent. It can pick up more liquid. Does that make sense?
Yeah.
So, given what you know now, the cheapest was A, less than a penny each, and the C was most expensive, but the C is more absorbent. Which one would you recommend to buy? Chris?
C.
Why?
Because it's more absorbent than most of the other ones.
What about the fact that it's 3 times more expensive?
Even though it's expensive, it works good.
It matters how good it is.
Right.
It matters how good it is. It's not how much you pay for it. It's how good it works.
Because the A, you have to waste a lot of towels, but it's cheaper. But it matters how much do you clean.
So what would you recommend?
A. No, the C.
C. Amber?
C, because it's more thicker, it absorbs more, and it's a better value.
Joseph? Which one would you choose?
Probably A because it was cheaper.
Even though, like Jesus was saying, you might need to use a lot more paper towels to clean up the same mess?
Yeah, because then you could just buy a lot more.
You guys did a great job today. You worked really well in your groups, and it was interesting to see some of the results we have.
What the investigation did is it provided a more real-life example of how students might be coming across messy numbers or shapes that aren't easily calculated to find their area. Now the place to go is to really look at decimals and say, what are they and what do we know about them? Teaching is really creative in that there's no one way to do anything. The students are constantly challenging my thinking in that they think about the world quite a bit differently. And so it's challenging to try to present ideas to them in a way that is open enough for each of them to think about those ideas in their own way. And then on a personal connection, just being, you know, really pretty intimately connected with 24 people and part of their lives, and trying to have a caring, respectful relationships, really rewarding.
Funding for PBS Mathline's elementary school math project was provided by the U.S. Department of Education. To learn more about Mathline's video and online resources or other educational programs, visit PBS Online at www.pbs.org. You may purchase videos or program materials online or by calling 1-800-645-7354.
Actually, this is my first year teaching. Last year, I was in the 3rd grade room as learning assistant, like Heather Richards is in my room this year for 4th grade.
I think we did a nice job.
I wanted the students to see from this lesson, guessing, and how once they get some more information, they can take a more educated guess, a more close estimate.
We're going to find out some information about Johnny Appleseed, because today is Johnny Appleseed's birthday. Johnny Appleseed by Stephen Kellogg. John Chapman, who later became known as Johnny Appleseed, was born on September 26, 1774.
I try and always start a lesson with a hook or something that'll interest the children, motivate them, get them to think about it and ask questions about it, to draw their interest, because we don't want to give them something out of the blue that they're not going to understand and not really have an interest in.
He planted apples.
He planted apples.
Using the book, we like to try and tie in literature along with all. We try to do an integrated unit across the curriculum, so we tie in different things.
When the sawdust settled, there was no question about who had come out on top. John was pleased that the land for his largest orchard had been cleared so quickly. He thanked the exhausted woodsmen for their help and began planting. Johnny Appleseed gathered his apples in a bushel basket. We're going to look at our bushel basket here, and we're going to try and guess how many apples are going to fit in the bushel basket. Okay? So I'm going to pick your groups, and after I pick your groups, you're going to come on, take a look at the apples, look it over, take the bushel basket, look that over, and in pairs, you're going to write down your guess. Okay? Then we're going to bring the guesses up and take a look at them all together in a group.
How about
6?
There's like there should be like 10 layers, because there's like
a big
plus
bucket.
There's big apples like that big. About 60.
60, yeah.
Plus it can after you put them, it could get higher. So
it doesn't have to quit at the
It doesn't have to quit at the edge, because they might fill it up more, Yeah. Probably about, say, 90.
97.
Yeah, 90.
90?
Yeah.
You sure? But some of them are big, though. Some of the apples are big. They could take up a lot of space.
Yeah.
75? 75, 76.
75 apples? Yeah, 75 right now.
Maybe 10 across the bottom or something. And then up in layers. So maybe about 70 something. Yeah. Like 72.
Students need to develop their estimating skills because there's going to be a lot of times where it's not going to be an exact answer, so they're going to need to use an estimation. Okay, when everybody's ready, we're going to put our guesses on the board and take a look at them and compare them. Okay? Amanda, what was your guess?
75 apples.
Okay, you want to put that up on our chart under guess? Grab a piece of tape and put it right under guess, please. Zach, what was the guess for you and your partner?
59.
59? Okay, you want to grab a piece of tape? Put it up under our guess on how many apples in a bushel? Okay, Rebecca, would you put your guess up on the board? Okay. Okay, do I have everyone's guess now? We have all our cards up here and we're going to take a look at them? Correct? Okay. What do we notice about these guesses?
All are different, except for 2.
Okay, they're all different?
Yeah, except for 2.
Okay, which 2 are not different?
75 and 75.
75 and 75. What is the lowest number that we've guessed?
36.
36? 36 is our lowest number? Okay. What is our highest number?
85.
85. So let's look at these and where did most of our guesses fall? In what area did most of our guesses fall?
75.
In 75. So could we say that probably most people in the room think about 75?
Yeah.
Now we're going to gather some more information. We're going to do a little experiment and take a more educated guess, more like an estimate, okay? So what we're going to do is take the basket, the bushel basket. Okay, Devin, you want to hand me that, please? And what we're going to do is put 20 apples in there, just to see. Andrea, Zach, AJ, you want to put about 20 apples in there so we can all take a look?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
Okay, we're going to look at the 20 apples in the bushel basket, and based on this, we're going to make an estimate, okay? You're going to use the blue cards on your table and write the numbers of your estimate now that you have more information and you have something to look at, okay? So go back to your groups and then with the same partners, write down your estimate.
Maybe we should layer them like Alex is doing. Let's try it. But we gotta make sure we have all the apples in there now. There's all the apples. So there's 1, 2, 3, 4. 1, 2, 3, 4, 5. No, because that's still. Look at 1, 2, 3, 4, 5. Because look at 1, 2, 3, 4, 5. Yep, you're right. There's 5. About 100. Because look at 20, 30, no, 40. 20, 40, 60, 80, 100. 100? Yeah. Write it down, Alex.
Like 20, 40, 60, 80. Because here's the bucket. Here's 20. It's going to be more than 20 because 20 fill up almost the whole bottom. So, plus another bottom, plus another bottom, plus another bottom, plus another bottom.
I wasn't that surprised that they came closer with the estimate because they were using a lot of strategies, a lot of mathematical skills that they've picked up without really thinking they were doing math. They were measuring the apple and the height of the basket. Boys and girls, if you have your estimates, I'd like you to bring your cards to the carpet and we're going to put them up on the board like we did our guesses. So they were really using some tools that they had learned before to come up with a closer estimate. Keith, can we have your estimate, please?
100.
100. Okay, let's take a look at the estimates that we have now. They're quite different from our guesses, but we're going to put them in order from least to greatest. Which would be the lowest that we have?
64.
64. Okay. Okay, what would be next?
96.
95.
95. We have a low of
Right in the middle.
64, high of 120. And looking at our estimates, Rebecca, can you tell me where it's kind of clustered in, which numbers it's clustered around?
95.
95 and
96.
96.
100.
Have a couple of hundreds.
115.
115. So kind of a range between like 95 and 115. Does that sound like a good range to you for our estimates?
Yeah.
Right in between 95 and 115. Does everyone agree with that? Yeah. Okay, can I have a thumbs up if we agree with that? So our estimate is going to be between 95 and 115 apples per bushel basket, right? What we need to do now is find out how many apples we have in a bushel basket.
22. 23. 24.
Good job.
25. 26.
51.
52. 53. 54. 55. 56.
98. Now can we fit a top over here?
Yeah.
Are we going over? Are we going over or are we about right?
So you take this one out.
Take that one out? Now do you think we'd
So
be able to
it's
fit
90.
Wait, maybe we should move that one over?
A little bit over there. And put that one. 99 or 98?
We're at 90.
That.
We're at 97.
103.
And how do they match up to our estimate?
Between 100 and 115.
Are they within our range?
Yep. No, 100's close.
100's closer?
Okay, boys and girls, we're going to find out how many apples we had in our bushel baskets. Can everybody come up here and we'll look at the totals that we have?
98.
David, how many did your group come up with?
97.
Ryan?
103.
Rebecca? What did your group get?
96.
96. Zach?
101.
101. Thank you. About how many apples did we get per bushel?
100.
About 100? Does everyone agree with that?
Yeah.
Okay, so 100 did fall between 95 and 115. Yeah. So what can we look at? If we look at our guesses and we look at our estimates, what can we find out about how close we came to an actual count?
Real close.
Okay? Did we come closer when we guessed, or did we come closer when we looked at the estimate and had a little bit of information behind us? Okay? In looking at these numbers, did everyone get the same amount of apples in a bushel basket?
No.
Why do you think that is? How did we have 4 different groups come up with 4 different answers? Ryan?
Because apples are different sizes and shapes.
Because the apples are different sizes and shapes. Great. Ben?
Because the buckets were different sizes.
Okay, the bushel baskets may have been
And
different sizes, a little bit different.
Different, they could have been fatter and stuff.
Right. Does anyone have any other ideas? Okay, Rebecca, did you have another idea?
Yeah, because maybe other groups packed a different amount of apples into their buckets. Maybe they're about over the top.
Okay, great. Those are some great ideas, and you did a wonderful job in your estimating. So we have about how many apples per bushel basket?
100.
100. Okay, you did a great job. Now what we're going to do is we're going to talk about how many of these bushels would come from one tree. Okay? Believe it or not, one tree would have 22 bushels of apples. Okay? So if we have 100 apples in a bushel, 22 of the bushels are filled for one tree. Think about it. How many apples are we going to have for one tree? Okay, everybody think about it. Okay. Amanda, how many apples are we going to have per tree?
2,200.
Okay, when Johnny Appleseed planted his apples and his apple trees, he didn't really pay attention. Okay? He just scattered them all out. But here in Michigan, the Michigan apple growers are more concerned with that. Okay? So they're going to want to know that we had 2,200 apples per tree. Okay? So the Michigan apple growers are going to want to know, they've figured this all out, how many apples they're going to get. So they're going to need to know how many trees they're going to plant. Okay, and we're going to look at a chart that they've created to tell us how many apples and how many trees they're planning on planting. Okay, here's the information. I want everybody to take a look at it and see what you notice about these figures. Okay, we have the total number of apples, okay, total number of trees, the number of apples per tree. What do you notice about the figures that we have up here? Ben?
And the trees things, it starts in 20 and then it goes in, and then it keeps on going higher and higher.
Anyone notice anything else? Is there any other patterns that we're seeing?
They're both going two different ways. One's going down and one's going up.
Okay, one's going down and one's going up. What kind of pattern are the trees following?
Lowest to highest.
Okay, that's starting at 20, and it's moving.
21, 22, 23.
Okay, and it's increasing by?
Going down.
Okay, it's increasing by 1. Okay, from 21 to 22. Raise your hand if you see that. Everyone agrees? Okay, that we're increasing by 1? Okay. What about the number of apples per tree? What kind of pattern are we seeing there?
It's going from highest to lowest.
Okay. It's going from highest to lowest. And is it increasing or decreasing?
Decreasing.
It's decreasing by how much each time?
75.
75. Okay, are we thinking about an operation that we could use? We have 20 trees, okay? We have 20 trees planted per acre, and we're going to have the number of apples per tree is going to be 2,200. What operation are we going to use to find the total number of apples that we're going to get from that acre of trees that we've planted? Ben?
Oh, 20 times 2,200.
Oh, 20 times. Okay, so we're going to multiply 20 times 2,200 to get the number of apples. Okay? Does everyone agree with that? Can I have a thumbs up if we agree? Ben's correct in his operation. He's going to multiply the total number of trees by the total number of apples to see how many apples we're going to get per acre. So we're going to have to find this out. We're going to have to do our operation, like we talked about before, multiplication, and fill these numbers in. So we're going to do these in groups. Mrs. Richards is going to give you a smaller chart like this. We're going to do the operations in our groups with calculators, and we're going to come back and we're going to look at the information that we get. The students looked at their data and were able to analyze that as the trees increased, that there was the maximum amount of trees that they could have, and they stated that the trees would overcrowd one another, therefore they wouldn't yield as many apples. And they looked at the results and saw that there was a decrease.
From 25 down gives us less. If you get 25 tree, you get the most apples. It's the highest number that'll give us the most amount of apples. And the reason why 26 and 27 and 28 and 29 don't give us it is because the apples get too crowded because there's a lot of trees that they don't have any room to grow.
We should plant 25 apple trees.
We should plant 25 apple trees per acre?
Yeah.
And that will give us how many apples total?
45,625.
Okay, boys and girls, we're going to collect all our data that we've gotten. Okay? We're going to ask for the calculations that we have. Can group number 1 give me their calculation, their total number of apples for 20 trees?
For 20, we have 44,000 apples. For 21 trees, we have 44,625. For 22, we have 45,100.
Okay, group 2, can you give me your total for 23 trees? Yep. Let's look at the figures, and what do we notice about the total number of apples? As we plant more trees, what's happening? Everyone?
It gets more higher.
Does it get higher all the way down, everyone?
No.
What would be the best number of trees to plant so we can get the most apples? Everyone? 25 trees. Why do we want to plant 25 trees?
Because it has 45,625.
So if we plant 25 trees, we're going to get 45,625 apples in our acre. And that's what we're going to recommend to the Michigan apple growers, that they plant is 25 trees per acre?
Yeah.
I wanted the students to be able to actually see what a million apples would look like. A lot of times I think that the students just think it's just a number with a lot of zeros. We need to find out how many dots on this page. These dots are going to represent our apples. To do the computations for the million, I started out with just one sheet, and the students had to figure out how many dots or apples were on each page, and that gave them some practice with some multiplication and looking at an array with the straight lines. And then they had to use their strategies and think about what operation to use next to figure out the million.
Times 12, 120 equals 8,040.
Once they found out that there were 8,040 on a page, they knew that they needed to come up with a million, so they took the million and divided it to see just how many pages, or about how many pages, they would need to actually show the million. And we know one page equals 8,040.
So we times that with 8.
Are we going to times it though? We already have a million.
So we add it?
Think of some different operations.
Take away? Divide?
Okay, you're going to divide what?
8,040. Since that's what we started with and we had to find a million.
But what's our large number that we're trying for?
A million.
A million? And we want small groups of 8,040, right?
Yeah.
So we're going to take a million.
We got 0 and divide it by 8,040.
Okay, let's try that. Okay, what does that give us? About
124.
124. So we're going to say about 124 pages would be a million. Okay, so should we try that out on the calculator?
So I times 8,040 times 124.
Try that.
Nope.
Get to be it.
Yeah, when
Is it pretty close to a million though?
Yeah.
Pretty close, so maybe we might have to add a page. Did you multiply 125 pages times the number per page, 8,040? Okay.
Yeah.
So how many pages do we need to make a million?
125.
125, you guys agree? Okay, so we need to get 125 pages to show a million apples. So we're going to display this, we're going to put it out in the hall to show our 1 million apples, so the whole school can see how many a million apples would be. Boys and girls, we're going to look at Johnny Appleseed's apple orchard. What I want you to do is take a look at this apple orchard and just take a guess. Just look at the trees and take a guess how many trees you think he planted in his apple orchard. Johnny Appleseed's orchard showed the trees planted very randomly. I wanted them to see that with the grid. Now we're going to do more of an estimate. We're going to use these grids to find out how many trees are in one square. So it's a better estimating technique where they could count the trees in one square and then determine the number of trees in the whole area. Randomly pick a square.
21.
Okay, you have 21, and David, what did you get for your square?
18.
Okay.
1, 2, 3, 4, 5, 6. 1, 2, 3, 4.
When we use the grid to identify how many trees in one section and then multiplying it, it came a lot closer to the actual number of trees than if we just looked at the picture alone and guessed. So using the grid system is a very good way to estimate how many actual things we have in a picture. Here at Trombley, the students really think of the school as a community, and they like to share with one another. We've done things where they've shared plays and stories. So the students decided that they wanted to share their million with the rest of the school, and hanging it in the hall where all the other classes could see was a great idea, and really they could take ownership and show the rest of the students what they were doing and be really proud of what they were working on. We learned a lot of things about apples today. You did a wonderful job. I'd like to thank you. You all worked very hard, and we found out a lot of information. We found out how many apples in a bushel of apples, okay, about 100. When we did our chart, we figured out how many trees the apple growers would have to plant to get the maximum amount of apples. We also found out what a million apples would look like, right? We have that on the board. That's amazing, isn't it?
Yeah.
And we found out some great ways to use estimation with our grid. But the reason we did all this is because it's Johnny Appleseed's birthday. So we're going to celebrate. So I think we should sing happy birthday to Johnny Appleseed today. Don't you?
Yeah.
Okay.
Yeah.
Ready?
I'll start off.
1, 2, 3.
Happy birthday to you.
Happy birthday to you. Happy birthday, dear Johnny Appleseed. Happy birthday to you. And
can we get an apple?
Funding for PBS Mathline's elementary school math project was provided by the U.S. Department of Education. To learn more about Mathline's video and online resources or other educational programs, visit PBS Online at www.pbs.org. You may purchase videos or program materials online or by calling 1-800-645-7354.
This is PBS.